I'd like to talk about the 4 metaphors of lean. And a metaphor, well, you'll see. If you take a look at the very first, most classic lean metaphor, it came about in about 1999, and it was the metaphor of the cathedral and the bazaar. Many have heard of the cathedral and the bazaar. This was a paper written by Eric Raymond, and it was first published in 1999, but it's a paper that was probably written an essay some years before that. And what it was about was Linux. Because Eric Raymond was a software developer, software engineer who could not understand why Linux was succeeding. And in fact, he said Linux to him looked like a great bazaar of different agendas and different approaches, and to think that a coherent, stable system could emerge from something like that only if you had a whole succession of miracles. But the fact is, we've had a whole succession of miracles. We have a coherent, stable operating system that operates a whole bunch of the stuff that you use whenever you get on the internet, and it comes out of not the cathedral, but the bazaar, or the marketplace. Think about cathedrals. Before 1880, if you wanted to build a cathedral, you had to use stone. There wasn't structural steel, and you could only go so high. And you could maybe make these flying buttresses and get it a little higher, and maybe you had a little bit more property on the side, but that's about as big, that's Notre Dame in Paris, as a cathedral can get. And it was the biggest building in the city until about 1900, when taller buildings started to be built. Now, on the other hand over here, with a bazaar, you can add as many additional stalls as often as you want, anytime you want, if you had a little more property. So this can get as big as you want, but it doesn't seem to have any kind of plan. It doesn't seem to have, well, there's a little organization. Maybe the flowers are over here, and the fruit is there, and the fish are there, and the meat is there, yes, but that's about it. However, if you go there to shop on Saturday, because the market is from 7 in the morning until 2 in the afternoon on Saturday, you know you will get plenty of interesting and good food to eat. You're not sure exactly what. So this is 2 completely different organizational structure concepts. And the interesting thing is that this bazaar concept, which is the first metaphor for lean, has actually worked in lots of places for hundreds of years. This is Ljubljana, and this is a baker, a really good baker who had his own coal-fired, wood-fired oven right there in the middle of the marketplace. And he made some of the most delicious pizzas, I tell you, because I had a piece. And all around him were other stalls. It could be like this, although this happens to be Venice, and this happens to be Vietnam. You name the country, and we probably have marketplace pictures. And this is Peru. Interesting, colors are the same, but here they're selling potatoes, so that's how you know it's Peru. So a marketplace is a platform for small, independent businesses where you have an owner, maybe a family, maybe a few other people. They make their own decisions. They decide whether or not to come to the market. They pretty much do their own thing, and they are successful or not successful based on the decisions that they make. Think about the idea of a company being a platform for small, independent businesses. Doesn't sound too likely. Companies should be cathedrals, right? But consider Amazon Web Services. Started in 2006. It's about a, I don't know, $50 or $60 billion a year business right now. At the moment, it's composed of something over 3,000 separate services. They're adding approximately 300 services a year. And the services are really small, independent businesses, usually owned by a team, maybe a couple of teams, that are responsible for the business success of the service. AWS is absolutely a bazaar. It is not a cathedral. And it's possible to have that. It's possible to do that if you think differently than the way we thought when we built our cathedral companies. So the reason why Amazon happens to be the interesting example is because when Amazon was a young company, they were a big front-end system, big back-end system, and they were not able to keep pace with the growth of the market in the years 2000 and 2001. And so the management team had a big meeting, leadership team, and they said to Jeff Bezos, we need better communication. Ever hear that? We need better communication. Right? So Jeff Bezos says, nope, wrong. We need less communication. I mean, he wanted the company to get much larger than it was. And he figured if communication was the problem then, when it was what we know now as a tiny little company in 2000, then they would never be able to grow. And so he said, sorry, but we need to have teams that don't have to communicate. That's the bazaar style. You have little independent booths where people don't have to communicate. So he asked for 2 pizza teams, right? Like that. Teams that could be fed with 2 of those nice big pizzas for lunch. So we're talking maybe 8, 10 people. And that many people are responsible for an independent service, a little tiny business that they bring to the market. Maybe they combine some, maybe there are some platform teams and some service teams, but the fundamental structure is 6 to 12 people, a leader who acts sort of like a CEO. In fact, if they want a new business, they hire or pick somebody and say, here, go hire a team and start up with this service. It should do this. It should interact with these services. This is kind of the strategy. Go make it happen. And make sure that you understand the pricing so that we price it right, because we don't want to lose money on your service. These teams are separate organizations, and they only work on their service. That's all the people in this, and it includes everybody from operations to product to all the different kinds of people necessary to make that service successful. They are responsible for measurable external outcomes. Their outcomes are focused on end customers and maybe intermediate customers if they're a platform service. And they decide what they're going to work on and what process they're going to use. And there's a very strong effort to keep the teams from having dependencies between them. There are some, but they tend to be basically clarified by contracts at the API level at the edge of the service. So think about it. This happened in the early 2000s. Amazon Web Services as EC2 was first deployed 2006. And the reason why it happened is because Bezos said, we will have 2 pizza teams, and the organization couldn't structure with a big monolithic central database, so they actually had to split up into small services because the organizational structure and the system structure always want to match. That's Conway's law. And in this case, the organizational structure split up first, and the system structure had to follow. So by about 2006, they had what turned into the cloud. If you think about it, the cloud was first and foremost an organizational structure for Amazon, which then turned into a system structure which they figured out how to sell. And they do very well by it. So thinking about that, it was a method of changing the way communication worked. From the cathedral style, up and down, to the bazaar style. Lots of little independent services, maybe talking to the next door neighbor, but basically independent. So the reason why Amazon structured this way is because Jeff Bezos believed that if you don't have autonomous agents making autonomous decisions, your growth size is limited. It's the only way he felt to have really, really serious scale is to have autonomous agents. So if you think lots of communication is going to help you scale, you might think again. Less communication is needed for serious scale. So one of the things that Bezos says, and the last thing I'm going to talk about Amazon, because it's not a perfect company. I'm sure it has plenty of faults. But one of the interesting things that you see every year is Jeff Bezos does a letter to shareholders. And in the last letter to shareholders, he was asked, what keeps Amazon so vital? And he listed 4 things. The first thing he listed was true customer obsession. Don't forget that one. That's where you start. He says you can worry about profit, you can worry about shareholders, you can worry about lots of things. We worry about customers being satisfied. We believe that if our customers are delighted, we'll make enough money to stay in business. So we don't worry about financial stuff. We worry about our customers really happy. And the second thing he said is, you need to resist proxies. So what's a proxy? That's not working too well. There we go. So these women are weavers in Peru, and they used to take their weaving and give it to an intermediate person who would sell it in the city. Now they actually take tourists up to their little village where they have sheep and alpaca. They spin the wool, and they weave the garments, and they sell it directly to customers like us. And they therefore know exactly what people will buy and what they won't. They can negotiate directly the price and the issue. And it's helped to make their lives better because there's no proxies, no intermediaries between the women who actually do the weaving and the spinning and the customers they sell to that buy it. Proxies in our world. Jeff Bezos says, the process should never be a proxy. So you should not be able to say, oh, I followed the process, so I can't help it if it didn't work. Yes, you can. Following the process is a bad proxy. You should go for the results that the process is supposed to deliver, not the process itself. How many people have work with something in their organization called the business? Anybody work with the business? Okay. The business is a proxy for customers. Better not to have it there. That's just saying. A market study. It's a proxy for actually walking in the shoes of the customers and understanding and developing empathy. The product owner can act as a proxy, getting between the team and the understanding of the customers. So you have to watch out for that, because you have lots of smart technical people bringing a technical solution to a problem. You don't necessarily want an intermediate party that doesn't understand both sides. The more minds you have being applied to the problem, the better solution you're likely to get. So intermediaries between the people developing a solution and the people who have the problem are proxies, and you should try to have none or as few as possible. And the second thing for proxy is profit. Profit is a proxy for satisfied customers. It doesn't mean they're going to be satisfied if a good alternative comes along. Productivity. We're very productive. That's a proxy for good business. May or may not actually be important. Shareholder value. A terrible proxy that we people from the US have imposed on the rest of the world, unfortunately. Bad proxy. Ever hear of cost, schedule, scope? They're proxies. They are not end objectives. Unless somebody has proven absolutely that when you achieve the cost, schedule, scope, you will in fact achieve the reason for the project. Better to not even look at the proxies and to work directly towards the end results. So in the digitized world, we're going for disintermediation. That means getting rid of the middleman, getting rid of the intermediary person, and connecting people directly up with the end objective. This is a really good book by Jeff Gottlieb and Josh Seiden called Sense and Respond. And the subtitle is How Successful Organizations Listen to Customers and Create New Products Continuously. There's lots of good words in that. But what it is they recommend that teams maintain a continuous two-way conversation between the team and the marketplace. So you have small multidiscipline teams, and by multidiscipline I mean it includes design, engineering, people who understand the end customer, operations folks, the whole gamut. If it is clear on the strategic intent of what it's supposed to do, so the team knows what's our strategy, what are the metrics we're going to try to make go right, what are the constraints of the team, and in those constraints, they try to move the metrics in the right direction. So this is not about features. It's not about, cost, schedule, scope. It's about making some business success in the marketplace. They have freedom to act without permission from colleagues or from management, and I'll talk a little bit more about that later. And there's frequent, preferably continuous deployment, so they get market feedback, so they can maintain that continuous conversation, find out how what they just did works, and the team can then improve and go on to the next experiment they want to run. And in this world, learning is more important than delivering features. Learning what customers are going to love is what the objective is. And success is measured by measurable outcomes at the customer level, not by a proxy measurement in between. So that's my first metaphor. Thinking about development teams as independent little businesses in a bazaar. It is one of the lean metaphors. But what if, here's another one, you're in the hospitality industry, for example, and you have one great big humongous company or ship or something like that, and there's lots of teams, and the teams have to work together. Then what do? Because it happens. So for instance, on this ship, this is the one we take to take all these photographs, by the way. This is I call it a photography cruise ship. There's a captain. There's a crew that makes that does the anchors and stuff like that. And then because we have to go ashore and take pictures of all sorts of neat things, we go in Zodiac, so there's a landing crew that takes the Zodiacs out and puts them away and gets us in them. And then there's a landing crew that helps us get ashore and takes us for walks on shore. And there's a hotel team that cooks food, makes sure that our beds are made and that sort of thing. There's an entertainment crew that has evening programs and things like that. And there's an expedition leader, and she was actually our expedition leader a few times. This has to be in the Arctic because she has a gun, and the gun is because there are polar bears nearby. So you don't want to be on shore without somebody with a gun. And now, think about that ship. You cannot have each one of those teams making their own separate decision about what to do. You can't say, I want lunch at 7, I don't care where we are. You can't say, I want the boats ready to land here, I don't care if you're eating or not. They have to coordinate their efforts. And there are dependencies between them. The captain has to decide where to be at what time of day so that if it's nighttime, we're not expected to be on shore. Those kinds of, lots actually of coordination, especially when weather gets in the way. So an expedition has a lot of teams. And the question is, how do they coordinate? Well, the most important thing is that every team has exactly the same objective. And that is to make sure there's an awesome customer experience. And so they coordinate on that focus on awesome customer experience. Now, if you have a lot of teams in a company and they have to coordinate on something, the best thing for them to coordinate on is the same objective: make customers awesome. Make sure that it's focused on being what the customers need in order to have an awesome experience. So you coordinate teams with a shared goal, and within the constraints of that goal, then the teams can act independently. That's the second metaphor. So now I have two metaphors here. One about individual agents, with teams doing whatever they want, and one about teams coordinating across for a shared goal. It depends which direction you go. A lot of coordination, a lot of individual teams, depending upon your context and the kind of thing you're trying to accomplish for customers. But usually it's dictated, if you do it right, by what is going to make the customers the most successful and the most awesome. With a bias, in software for sure, towards independent, as few dependencies as possible. I'll do more on that later too. Now here's my third lean metaphor. So perishable goods. And Tomek said, maybe I should explain what that means. Perishable goods, stuff that gets bad, like flowers after a few days wilt, and milk goes sour, and berries get bad, and the stuff that has to move through the supply chain really faster, by the time it gets to your table, you can't eat it anymore. In Minnesota, where I live, we actually get berries from Peru or Chile, yes, especially from Chile, in the wintertime, all the time. And in the summertime, more likely from Mexico than anywhere. If you know how far we are from Mexico, that's not. So that value chain, that chain of moving from being picked to being delivered to our house has to be, to our grocery store, and then to our house has to be really fast. So that is a really good metaphor for lean. And this is flowers in Amsterdam. There's a great big flower, in the spring there's a great big flower. This is where these things are going to ship all over the world, and they come in trays, and then they have a great big bidding. This is where people bid on. Okay, so they're bidding on this cart of flowers, and this counts down, and these people here are buying them by being the last person to hit the price that they're willing to pay. And the one who hits the lowest price, they get it. This is a very, very rapid way to bid and pay for all of these flowers going through. Because they don't have time to do anything much more than have a really fast bidding process. So when speed is the thing you're competing on, when your competitor is fast, when speed matters at all, the thing you have to think about is, how do I think about efficiency? What does efficiency really mean? And in lean, the bias is for flow efficiency over resource efficiency. That is, making stuff move from start to finish through the value chain as fast as possible is much more important than making sure that everybody is busy all of the time. And if you think about perishable goods, these, what is this, calamari and shell, they have to get to me or to whoever's going to eat them really fast, or they're not going to taste very good. Similar, these strawberries don't last more than a day. Not in that style. And what you want to do is think about, it's all about rapid flow from harvest to consumption. When that is true, then in a perishable goods supply chain, here's what doesn't matter. You never optimize for resource efficiency. Why would we do this on a bike? Why don't we just fill up a truck? It could wait for a few hours until it's full and then bring it all to the market. That's not even a concept in a perishable goods supply chain. When it's there, it moves. If the truck isn't full, too bad. If the plane isn't full, that doesn't matter. It moves as fast as possible. So you never optimize for making sure that all the resources are completely full, because if they are, then actually, let's just say all the planes are full. I've got an extra box of berries. It's going to truck of berries, 3 trucks of berries. There's no space on any of the planes. They're full. Then they're going to spoil. So you don't try to fill everything up, because that says you're going to have whole batches of stuff that get stuck behind and spoil. So if you think about it, in a perishable goods environment, the most important thing is always making sure then when I have something, it moves, right? If I got a truck of berries, it better get on that plane. If I've got a plane landing, it better get to the grocery store now. And you focus on that movement. You do not focus on making sure that all of your trucks and all of your planes and all of your people are busy all the time. Doesn't make sense. You never accumulate big batches of stuff. Never. Because that's the best way to slow everything down. The speed through your system is measured in the size of your batches that are waiting to move. If they're small, you move fast. If they're big, you move slow. You aggressively discover and eliminate the biggest bottleneck in your system, and then you do it again, and then you do it again, so that I can get from Santiago to Eden Prairie in Minnesota in about 10 hours instead of 20, or whatever. And you use the consumption to pull. So you don't want any more stuff coming to my state than we buy. The more we buy, the more we get. And so you use what people are doing to pull. And you leverage consumer feedback to figure out if people are buying a whole bunch more raspberries than blackberries, maybe I should be producing more raspberries because that's what people like. So resource efficiency in this environment is nowhere near as efficient as you would think it is. It actually is a really bad idea. Now, if you could just understand for perishable goods why resource efficiency makes no sense, simply is not a good idea, and then translate that into your world. If being at all, any kind of speed matters, all of those things you do to be quote unquote efficient are actually not a good idea at all. They're probably making you less efficient at the high system level than if you were not trying to make all the resources efficient. Completely full resources, like a completely full highway. Say you leave here and you go onto a completely full highway because everybody's leaving at the same time. That's called a parking lot. Okay, it's not a highway anymore. It's too slow. And anything you do to fill up all of the resources slows everything down, and if speed matters at all, then you worry about how do we not have resource efficiency? How do we have flow efficiency? So in our world, we should be thinking about what does it take to build a deployment pipeline? Now, this book here, Continuous Delivery, was published in 2010. About 2 years later, so say 5, 6 years ago, people started being able to do what was recommended in this book, various modes of continuous delivery. And that whole concept of continuous delivery became really common. Today, most companies have figured out how to do it. It's an acceptance test-driven development process. Cross-functional teams include product, include QA, include ops. You do automated build, automated test, automated database migration, automated deployment, incremental development on the trunk, so trunk-based development, and that trunk is always ready to deploy. Might not be deployed all the time, but it's deployed frequently, and at any point in time, it is tested and ready to deploy. And software is always in production release state. And if not, the top priority is to get it there. So stuff always works. It's always been tested. You don't have the concept of after everything's done, I'm going to test it. It's always tested. It's always ready to deploy. And you deploy all the time, and if you're not actually ready to have what you deployed, ready for prime time, and then you turn it off with a switch and turn it on when it's ready to release. So release and deployment are two different concepts in this flow world. When you can do that kind of flow, you can really move stuff through your pipeline very fast if, well, there's a couple of other bottlenecks. It's not this easy. Two big bottlenecks in software development. One is handoffs, and one is dependencies. And remember, in a flow world, you try to figure out how to get rid of the bottlenecks as fast as you can. So the best performing teams are the ones that don't have these bottlenecks. They can act without permission. They don't need permission of another organization, or they don't need permission from dependencies. This was in the 2017 State of DevOps report. Teams that can act independently by themselves are the ones that get the most done. So let's talk about handoffs. To minimize handoffs, the concept is to build whole teams that stay together and work together over time. Complete teams. You do not separate knowledge of what to do, responsibility for getting it done, the action that the team has to accomplish, and the feedback from the results, which then go into that loop again. So one team or a very small set of teams in a continuous loop, and inside of that team is everything necessary to do all of those things. Knowledge, responsibility to get it done, action to make it happen, and feedback from the results. And Alan Ward says in product development, he's the guy that's written a lot about hardware product development, the biggest source of waste is handovers from one department to another. We have a lot of that too. We're trying to get rid of it. But if you have a business to IT handover, that's a big deal. That's a handover. The other thing we need to do in order to be able to have flow is to break dependencies. And I think dependencies is one of our most massive problems in software development, probably brought on by the fact that once upon a time, we thought it was a good idea to have great big databases that were all integrated across the company. Remember that? We need our integrated ERP system that matches all of our customers and everything like that. Well, guess what? That big central database is the biggest dependency generator you could possibly imagine. Every time I make a little change in any spot, I have 50 million things to worry about. Those dependencies generated by that central database are killing us. So it's interesting that in the world of microservices, the architecture gets rid of the concept of a central database. It's gone. When I first heard Amazon was operating all of their retail sales with no central database, I thought they were crazy. But they're not crazy, they're smart. They got rid of dependencies. So in the microservices world, you have one of those full stack teams. You don't separate knowledge, responsibility, action, and feedback. You have independent deployment. If you think you're doing microservices, then the way to decide is whether or not, two things, is a service small enough the team could rewrite it in a couple, 3 weeks, and can it be deployed independent of any other service? By definition, microservices are independently deployable. There's local persistence instead of central persistence, and there's extensive automation so that you can move through your flow real fast. So oftentimes I hear about communication problems. We talked about that in the last 2 metaphors ago or something like that. If you're putting in place a process to help improve communication, you should think maybe I have an architecture problem as opposed to a communication problem. And don't attack architecture problems with communication systems, communication processes. Well, temporarily, maybe it's okay, but if your fundamental underlying problem is an architecture problem, you should know it and you should attack it, because if you're going to put a process Band-Aid on top of a fundamentally technical architectural problem, you're never going to get out of your problem. So if your problem is architecture, do something about the architecture. The last metaphor is scientific research. So this is my daughter-in-law. She just got a PhD in indoor air quality. She has a little baby about the size of that cool little kid that was in here. I think she left, but that's okay. We were just at a conference in Helsinki, and in every single room there were 5 or 6 little toddlers, infants. It was really fun. Because my son and daughter-in-law have a 4-year-old and a 7, 8-month-old now, and we can't wait to see him again. So she just got this, 2 weeks before the baby was born, she got her PhD. And at the University of Maryland, you can see this. And the thing about that is, when we think about learning, one of the metaphors you can look at is how do scientists learn, and how have they learned for the last several hundred years? So in centuries of figuring out how to learn, typically the major professor in an area is the mentor of the junior person, helping them to do their own research, but the mentor pointing them which direction to go and guiding them and learning how to do things. There's a lot of curiosity, but in the end, you have to focus on something. You use a scientific method. A little bit more about that later. But the scientific method is a pretty standard way of figuring out how to think about things in which you create hypotheses and then attempt to disprove them. Peer review. If you don't have peers looking at your research, it almost doesn't count. If it hasn't been published, it isn't real. And if you haven't kept a lab book of everything you've done so that you can then record the important stuff in some other way, then again, it doesn't actually count. It hasn't happened. So we can do experiments, but if we aren't keeping track of what experiments we do and what we've learned from them, then we're not doing the kind of learning that serious scientists think about as learning. And they do it continuously. They don't stop. There's no branch of science that comes to an end. It just keeps going. And remember, if it hasn't been confirmed, reviewed, and shared, it hasn't been learned. So Alan Ward says, and I totally agree, that learning is the essence of product development. It's what you do when you develop a product. And learning is the most important thing. So think about, how do we learn? How do we set up and structure learning? So learning is like the last of the 4 big things in Lean. So let me ask you, what's the biggest waste in software development? Bingo, yes. I totally agree. The biggest waste is basically building the wrong thing. Yes? And we do it all the time. And if we want to have a more efficient process, it's not about keeping everybody busy. It's not about any of that. It's about learning what's the right thing. And we have to focus our attention on that. Now, we have, some of our processes have outsourced the learning to somebody else. I suggest it's not such a good idea. So for example, half the time the product manager's idea is not going to work out, approximately. So Marty Kagan, I'll show you the book he's just written, is called Inspired, and he said, good product managers have lots of ideas, and you actually don't expect them to be right all the time. Half of them are wrong. If the process requires them to be right, they can pretend, but fundamentally, they have ideas that need to be tested just like any other person, and in fact, if all of your ideas are coming through a single person with a single perspective and a single background, you have a lot of very limited ideas. So it's nice to have a product manager to help the team understand what the customers are thinking, but certainly that's not the one source of what the team should be to make sure that they're doing the right thing. What if you have a spec? Well, in a spec, 2/3 of the functions and features in a spec, baseline numbers, probably don't need to be there. They're extra because people just put in stuff, you know, because it's fixed price or whatever. So if you get these slides, there's some references to some of these numbers. But baseline, when teams are given stuff to do, half to 2/3 of the time, it's actually not the right thing to do. So what do you do about that? You stop having delivery teams and start having problem-solving teams instead. I mean, it's not like it's a bad idea to have a product person on the team. It's just a bad idea to have the product person tell the team what to do. Because the product person brings their perspective, the designer brings their perspectives, the engineers bring their perspective, and with all of those perspectives together, you use classic learning processes to figure out what customers actually would love. So we don't want this. Here, there's your job, and we're going to measure how well you're doing. What we want is problem-solving teams instead. And we want processes that support problem-solving teams. So one of the main things you have to do is stop measuring the outputs. How many features does this team do? Because remember, features are more than half the time likely to be bad, junk that fills up our code base that didn't need to be there. You measure productivity based on features, and you're measuring productivity based on how much junk can this team put in the code base, how fast. That's really not a good measure. You want to measure how successful is what the team puts in the code base going to be make the product. So you want to measure outcomes, not outputs. So in learning what to build, we have in the lean startup environment from Eric Ries this concept of build, measure, learn. Expand on that a little bit. The first thing you need to do is observe and imagine some ideas for what might make this a better place for those customers. And then maybe build a, this is Henrik Nieberg's picture for minimum viable product. If you haven't read his blog on this, it's a cool one. So you want to build something simple, and then you want to make it more complex. You want to do experiments and validate that this was in fact a good idea. And you want to do this over time. So if you think about it, the team's job is to discover what makes customers awesome. For a whole lot more on this, Marty Kagan has written a book, Inspired, about 10 years old, and he just came out with the second edition, which is way better. So don't even bother to read the first edition anymore, because this is actually a pretty good description of how to discover what customers will love, written from the point of view of the job of a product manager. The process whereby we learn what it is that customers are going to love is a pretty classic standard learning process. I told you I'd tell you a bit more about the scientific method. So what the team does is it starts with signals, patterns, something from the market, not requirements. So we don't know what the requirements are. We know there's an issue, a problem, a frustration, something like that. You focus on problems or some major change that needs to happen. I was with a company in Netherlands, and their teams were always looking at social media with artificial intelligence to find the latest customer frustrations, for example. Then you say, this is a frustration we're going to kill. We're going to get rid of this frustration. So you plan with hypotheses. Let's face it, any feature request at all is a hypothesis that if I do this feature, I'm going to get this result. Let's be honest about it and recognize it's a hypothesis and treat it like a hypothesis. Now, you don't estimate hypotheses. You state them and try to disprove them as fast as you can. The more hypotheses you can deal with, the better you are. In fact, if you are not having hypotheses that are proven wrong, you surely are not thinking very hard. If everything you try is successful, then you are really not learning anything. You really need to have hypotheses that are disproved and some that are proved. Then you have looked at a range of possibilities and have a much better chance of getting something that's actually going to be a brilliant solution that makes customers awesome. You don't have a backlog of stories, you run multiple experiments. And in Inspired, Marty Kagan shows how designers can actually do multiple experiments with customers with very simple prototypes really early, way before you even write code, and way before you even do a minimum viable product. So there are design techniques to figure out what we should actually start producing code around, and you can start validating customer interest well before you start writing code. That doesn't mean the team isn't involved, however. Of course they are. And so you do a lot of experiments, and then you use the data from the experiments to decide instead of having people guess. It doesn't matter who's guessing. It doesn't matter what their role or title is. They're guessing. If you haven't validated it, it's a hypothesis. So this is the proven learning process. And if your development process doesn't look something like this, you might ask yourself, why not? Because it should. Because this is how you learn. Now, you do the same concept with process problems. I'm not going to talk a lot about it, but this whole concept of constantly learning is one of the really 4 pillars of lean. So let's just summarize the 4 metaphors here. One is no proxies. The marketplace, where the team and the market and the customers are in direct, immediate contact with each other. No proxies in between. The second metaphor is making sure that if you have multiple teams, they coordinate with each other to create an awesome experience for customers. And that the customer experience and the awesomeness of it is the focus of all of the teams. Another one is flow, rapid movement through from idea to actually out there at least tried and validated or invalidated. And that's something that needs to happen fast. And the other is learning. And learning isn't necessarily need to be fast. It needs to be steady, it needs to be carefully thought out, and you move faster later when you've learned enough to do it right. So in product development, there's a time to learn, and there's a time to move fast. And it turns out actually in hardware product development, learning first is even more important than in software product development, because learning cycles are more cumbersome and take a lot more time. If your learning cycle is fast, you can have a lot of them. If your learning cycle is slow, you want to be careful you learn all the stuff that's hard to repeat before you go ahead and build. But in any case, whether it's fast flow and slow knowledge, direct contact, or maybe coordinating across, it's always customer focused and it's always about learning. Now with these four things, you might see it's not that different than modern Agile. Have anybody looked at modern Agile at all? It's about continuous delivery. It's about a lot of experiments. It's about making people awesome, especially customers. And it's about making the team a safe place, or basically a place where people can do their own thing. So if you think about those four things, you have a sort of a really good basis of what does it mean to have lean in your everyday work. So with that, that's the end of what I have. Do you think we have any time for questions? The question is, has that business manager ever put a successful product on the market from the bottom? My observation, because I tended to work for managers who had done my job, was when I was working for managers who had done my job, I never had much trouble convincing them about the important issues that I was facing. If you have business managers that have never put a product on the market, they don't have much clue. If they think they can just use financial metrics and make it happen, you know, best of luck, but they haven't actually done it. So what you need is managers that at least listen to people who are enmeshed in the middle of making stuff happen and respect the struggles that they're having and try to figure out how to make those struggles less. And that's just basic respect for the people and teams on the front line. So in a lean world, the most senior leaders are expected to spend their time watching what's going on at the front line, observing it, understanding what the issues are, and only then do they make decisions about what's good and bad, and not too many of them. So I can't tell you why those managers are so hard to convince, but I'm going to guess it's proxy metrics, bad metrics. And so I think you need to think hard about why companies are being run with bad proxy metrics.
The second most popular question is, at the end, when whole team contributes with ideas and all of them seems to be good, who should take the final decision of what should be done?
First of all, you do not want a long list of what should be done, and you don't want something you have to juggle. One of the concepts is to have a very short list, and you decide what to do next based on what you've just learned. So if your loop is short and you don't have this thing called a backlog, you have just a small number of things to do next. Typically, you have in a team, say 4 or 5 engineers, 1 or 2 designers, a product person, maybe somebody to help with quality, maybe for sure somebody in ops if it's software. And that group of 5 to 7 people has been, or 8, 10 people have been working together for a long time, and they know how to work together, and they know how to make decisions together. And as a group, if they can't decide, but usually they can come to an agreement because that's not a big group, then there tends to be at that point somebody who basically says, okay, we really need to prioritize this and go this direction. But my observation is that when the team decides on one thing is at a time, and then the next thing, and then the next thing, and they learn how to work together, and they're all trying to achieve the same goal, it's not so hard for them to come to an agreement on what should we be working on next in order to make our thing best. And in fact, what I oftentimes like to see is that the team is trying 2 or 3 things. Especially, let's say you have a team of 8 people and there's one person who just has this great idea. She really thinks it's going to work. And only one other person thinks she's right. You know, there's no harm in letting those 2 people go off and try their thing. Maybe she is right. And maybe with a little bit of help from 1 or 2 colleagues, she can prove that she's right. But it's a fragile idea to begin with, and it needs to be explored. So there's nothing wrong with trying 2 or 3 things at the same time and seeing which one proves out best. It's a really classic lean product development technique to try 2 or 3 options and to see which ones get eliminated rather than to only do one thing. So maybe you don't have to. Maybe you can take the person who's passionate about something and let her go off with a couple people and try their thing, and then have a few other people go down this other path and see which one turns out to be the best.
The companies like Amazon will make decisions based on data. Google as well. People try experiments, they generate data, and if the data indicates that the idea is working for the goals of the group, then it's adopted. If the data do not indicate that, well, the idea is to get the data as inexpensively and quickly as possible so that you learn something at a minimum cost.
There's a wonderful story, which I believe is mostly true, of a guy who worked at Amazon who wanted to do something. Basically, once somebody had decided to purchase something, they would say, you know what, people that purchase this also purchase these other things too. Why don't we recommend some associated purchases? Have you ever seen that on Amazon? It didn't used to be there. And this guy thought it was a good idea. And the vice president of marketing, the very most senior marketing person in the company, told him, you don't know anything about selling. Let me tell you something. Once a person has decided to make a purchase, you do not distract them with other things that they might want to do. That is a no-no in selling. And you know, if you're selling, you'd never do that. But this guy thought maybe it would be okay. So without any permission, and in fact being told to forget the idea, he went off and he put together some experiments anyway. And those experiments proved pretty dramatically that they had a very significant increase in purchase when people were presented with associated things that they might like at the same time. When the marketing director found out he did these experiments, he was pretty upset, but he couldn't deny the data. And so they did, in fact, put the recommendation thing afterwards, and of course their revenue went up right away. So we learned at 3M when I was doing product development, don't ask for permission, ask for forgiveness. I think that's a pretty good Polish saying, yes? And so the idea is everybody doesn't have to agree on the right way. Maybe you try a few things instead if you absolutely can't come to an agreement. And there's one more? However many. It's fine with me.
How does Amazon Teams know how to make a customer feel awesome? Do they use proxies for that?
What they're doing is looking at sales numbers, okay, that sort of thing. So a typical metric in a web-based company that does a free thing and then a paid thing is the conversion rate from people trying the free thing, what percent actually convert to paying. So in Amazon, I'm pretty sure that they're looking at usage rates, and also they're looking at when somebody starts to use it, at what rate do they increase their usage. So that doesn't seem to me to be a proxy measurement. That seems to me to be a metric of measuring how much your customers actually like and are using your product. You have to be a little careful on those things, but what you're trying to do is measure actual customer results rather than is the feature deployed. So outcome metrics are how the customers are actually using it and the rate at which they start using it more, stuff like that.
Okay? And how to balance fast delivery with quality of delivered product.
Wait. That's not a balance. Okay. You have to have been involved in any kind of lean environment to know that the only way to go fast is to have highly disciplined, high quality, or you can't go fast. In our manufacturing plant, when we started just in time, we had an associated quality program because you can't move fast and just in time and pull unless everything works. If you have bad quality, it falls apart. You will always see high quality when you see speed. And in fact, with continuous delivery, you have to have high degree of discipline on quality to make sure that the deliveries can go down the pipeline with a high degree of confidence and a very limited blast radius should it blow up, that it's going to be a problem. So the faster you move, the higher your quality has to be. Used to be you could do manual quality control, not with continuous delivery. It all has to be automated and it has to be precise and it has to continually get better. I've never seen high speed and low quality ever work. Doesn't. So they go hand in hand. And that's why you do, one of the things you always get with high speed is you get a high degree of discipline because you simply can't do anything at speed without a high degree of discipline. Think about the Olympics and people like zooming down the hill. The only ones who can go down the hill on skis really fast are the ones that have a really good idea about what they're doing and really good control of the situation. It's the same with any kind of speed through any kind of process. The only ones who can make it without killing themselves are the ones who are really disciplined, really expert, and really know what they're doing. So that is not a trade-off. You can decide which one you want to do first, but you cannot do speed without quality. Just doesn't work. You crash. You can imagine, and it's my metaphor, you're falling halfway down the hill and you're crashing, and I hope you survive, you know? But you can go fast if you've got all the discipline that surrounds it to make sure that you're not going to go off the rails at any point down the hill.
Yeah, how do you recommend to measure a focus on flow efficiency?
How do you recommend flow efficient to management? The way that we like to think about it is to think about in any given amount of work that can be assigned to a time card, how much of that is actual value-added work, how much of that is superfluous work, and how much of that is failure demand. So superfluous work is work you don't really need to do. You're only doing it because you're trying to do several things at the same time. So there you ask yourself, so if I had everything I needed to accomplish this, all the people, all the other resources in the same room at the same time with nothing else to do but this, how long would it take? Okay? How many hours would it take? How much calendar time would it take? If you answer that question, then any other time spent on accomplishing that is superfluous extra work. So think about what's going on. How much of the work in your organization, if it were totally dedicated with the people completely available all the time, how much of the work you're doing is just to compensate for the fact that that's not true? Number one, all priority setting wouldn't be there. That's compensation. Number two, all teams waiting for somebody else to be there. And the second one is failure demand. So I'd say if you break up your work, you're going to have a third of it going to be actual value-added work, a third of it this extra work to handle all the thrashing from overloading resources, and the last third is failure demand, and that is demand on your resources there because you've made a mistake. You know, it's technical debt, or it's I put a bug out there in the system and I have to fix it. How much of the time are people spending fixing stuff that shouldn't need to be fixed in the first place because they should have been done right? And that tends to be about a third of the time too when you think about an overall view. So if you can look at the environment and say, I'm going to bet, you know, base rates, a third of this work is value added, a third of this work is superfluous work, and a third of this work is failure demand. And if you can even identify that, then you can show, whether they'll believe it or not, I won't tell you, I don't know, but the fact is that probably only a third of the actual work being done is adding value. And if you could just do that third and not the other third and not the other 2/3, then you'd have a whole bunch more time to actually do more value-adding work. So it's hard to think about, but the focus of Lean is to just do the value-adding stuff and quit doing the failure demand and quit doing the superfluous work by having this straight-through flow. Thank you.